Today, we're going on an incredible journey, a virtual mission right to the heart of our solar system. We're about to explore the star that makes all life possible, our very own sun.
Okay, our mission briefing starts right now, and I promise you, what we're about to uncover is going to be absolutely spectacular. You think you know the sun? Well, let's find out.
So let's start with a sense of scale because this is just staggering. I want you to picture our planet Earth. Now imagine trying to fit 1.3 million Earths inside the sun. Yeah, that's not a typo. 1.3 million. The sheer size is almost impossible to really wrap your head around.
And the temperature? Whoa! The difference is just astounding. The surface we actually see, the part called the photosphere, is a blistering 5,500 degrees Celsius. But honestly, that's practically cool compared to the core, which rages at over 15 million degrees Celsius. That's where the real action is. So how in the world does it get that hot? The answer is a little thing called nuclear fusion. Deep in the core, the pressure and heat are so intense that hydrogen atoms literally smash together to form helium. And that process, it unleashes an unimaginable amount of energy, which is the source of every bit of sunlight and warmth we feel here on Earth. So, with that incredible power source in mind, let's start our descent. We're going to travel from the core all the way outwards and see how this star is built, layer by fascinating layer. Okay, let's do a quick tour of the sun's layers, from the inside out. We start at the very center, the core. That's the power plant where all the fusion is going on. From there, energy slowly makes its way through the radiative zone, a journey that can take thousands of years. Next up is the convective zone, where hot gas bubbles up, kind of like a giant pot of boiling soup. Then we finally reach the photosphere, which is the visible surface we see. And above that, you've got the reddish chromosphere, and finally, the super hot outer atmosphere, the corona.
So we've seen how the sun works, but let's bring the focus of our mission back home. Why is this giant ball of fusing gas so incredibly important to us?
Well, simply put, the sun is the ultimate fuel for all life. Its light is what drives photosynthesis, letting all the plants grow. Its heat keeps our planet's climate stable and drives our weather. Literally everything we experience is connected back to that solar energy. And you know, we've even learned how to harness that power directly. The sunlight that travels millions of kilometers through space gets captured by solar panels right here on Earth to generate clean, renewable electricity for our world. It is absolutely not an exaggeration to say this. Without the light, the heat, and the energy from our star, our planet would just be a frozen, lifeless rock. The sun is, quite simply, everything to us.
But the sun isn't always this calm, gentle life giver. Oh no. It has a wild, dynamic, and sometimes violent side. So let's navigate the more turbulent parts of our star, the solar storms.
So the action often kicks off with sunspots. These are the cooler, dark spots that show up when the sun's magnetic fields get all twisted and tangled up. But what happens when those tangled fields finally snap? You get enormous explosions of energy known as solar flares.
These flares, and even bigger eruptions called coronal mass ejections, are powerful enough to blast streams of charged particles right out from the sun, sending them hurtling across the entire solar system.
And when those particles reach Earth, well, they can create one of the most beautiful sights in nature, the auroras, those incredible dancing lights in the polar skies. But they also have a dangerous side. They're powerful enough to disrupt our satellites, our communication systems, and even knock out power grids on the ground. Okay, let's pull our view way back and get a wider perspective. Because beyond its energy and its storms, the sun plays another equally crucial role. It is the anchor of our entire solar system. It's the sun's immense mass that creates this incredibly powerful gravitational pull, and that's what locks all the planets, from Mercury all the way out to Neptune, into stable orbits. Without that constant pull, Earth and all the other planets would just fly off into the cold, empty blackness of deep space.
So how do we know all this stuff? It's not like we can actually go there, but we have the next best thing. Let's look at the incredible modern explorers, both human and robotic, that are our eyes on our star.
Scientists use a combination of super powerful telescopes, both on the ground and in space. But our most daring explorers are missions like NASA's Parker Solar Probe, which literally flies through the sun's atmosphere. And then there's the European Space Agency's Solar Orbiter.
These robotic explorers are crucial. They help us understand and predict solar storms, which is so important for protecting our technology back here on Earth.
All right, our mission debrief isn't just about what the sun is doing right now, but also about putting its awesome power into perspective. So let's wrap up with 3 final facts that do just that.
First up, a little perspective on time and distance. The light from the sun's surface travels at the fastest speed possible, right? And yet, it still takes 8 minutes and 20 seconds to reach our eyes. That means we never see the sun as it is right now. We're always seeing it as it was over 8 minutes ago. We are literally looking into the past. Next, perspective on just sheer dominance. Get this. The sun contains 99.8% of all the mass in our entire solar system. Every planet, moon, asteroid, and comet, all of it combined, makes up a tiny leftover 0.2%. That's why it's the anchor. It is the undisputed center of everything.
And finally, a little perspective on its lifespan. Right now, our sun is a stable, pretty much middle-aged star. But in about 5 billion years, it's going to swell up into a red giant, before it eventually shrinks down to become a white dwarf. But don't worry, that is a very, very long time from now.
So this incredible journey, from the sun's fiery core to its far-off future, it leaves us with one final big question. If our star alone holds 99.8% of our solar system's mass, completely dominating our neighborhood, what other incredible secrets are still hiding out there in the vastness of space, just waiting for us to find them?